Hello friends. So in the last video we have seen the second type, that is vector or cross product properties, and two more examples. One more example we are going to solve based on the same type, okay, and which is important as per the examination point of view for 3 marks. So the question is, find a unit vector perpendicular to each of the vector a plus b, a minus b, where vector a is equals to I plus j plus k and vector b is equals to I plus 2j plus 3k. Okay. So in this problem, if you read the question, you have to find out the unit vector to vector perpendicular to each of the vector. After reading this question, maximum students what they do is they find a plus b, a minus b, and they check it for perpendicularity. Means what? They check their dot product. Okay, but this problem is of that not type. Okay, means it is not of the first type. Okay, so this is of the second type, where cross product or vector product. So how to simplify this? It can be simplified in 3 steps. First, we have to find a plus b, a minus b. Next, we have to find their cross product, and then its magnitude, or you can say its unit vector. Okay, so see here. So first, we have to find a plus b. Just do the addition of that. 1 plus 1, 2i plus 3j plus 4k. Okay, next a minus b, subtraction. 1 minus 1 0, I is absent. 1 minus 2 is minus j. Next 1 minus 3 is minus 2k. Once you find a plus b, a minus b, next you have to find a plus b cross, okay, that is a minus b. Means we have to find the cross product of that a plus b and a minus b. And you know what is the formula for cross product? Determinant of I, j, k. Or second row is the components of a plus b, that is 2, 3, 4. Third row is the components of a minus b. I is absent, so it is 0, minus 1, minus 2. Okay. Now expand this with first row. So I into, leaving the first row, first column, minus 6 plus 4, minus j into, leaving the first row, second column, minus 4, minus 0. Okay, leaving the second row, second column, that is minus 4, minus 0, plus k into, leaving the first row, third column, minus 2, again minus 0. Answer is minus 6 plus 4 is minus 2, it is minus 2i. Minus 4 minus 0 is minus 4, minus into minus plus 4j. Minus 2 minus 0 is minus 2 into k is minus 2k. So this is your a plus b cross a minus b. But after finding this, we have to find out the unit vector of this. So to find the unit vector of this, denote it answer by another name, that is c, vector c. Now you have to find out c cap, that is the unit vector. Formula is vector c divided by magnitude of vector c. So vector c is what here? Minus 2i plus 4j and minus 2k divided by magnitude. So it is root of coefficient of I square plus coefficient of j square plus coefficient of k square. I think you know that. Minus 2 square is 4. 4 square is 16. Again minus 2 square is 4. So the answer is, that is minus 2i plus 4j minus 2k divided by 16 plus 4, 20, 20 plus 4, 24. Okay, this is the answer. Still, if you want to simplify, then this 24 can be written as what? 24 can be written as that is 4 into 6. Okay, so again this can be written as 2 root 6. Even this also you can do it. Okay, but if you keep the answer as it is, no problem, you will get the marks. Okay, so this is the one problem I have solved it from the vector or cross product. Now your next type is scalar triple product. Scalar triple product. This is the last type of your chapter. Okay. Now, firstly we have studied with scalar or dot product. Second, vector or cross product. Third is scalar triple product. Now, suppose there are three vectors: vector A, vector B, and vector C. So these are the three non-zero vectors. Then scalar triple product of these three vectors, vector A, vector B, and vector C, is denoted by, that is, square bracket of A, B, C. So square bracket of A, B, C. Now you have to read as what? Scalar triple product of A, B, C. Okay, or this is also written as A dot B cross C. A dot B cross C. This is another notation for scalar triple product. So both the notations we use while simplifying the examples, but both gives the same meaning, that is scalar triple product. Okay. Now let us learn with the properties or the observations of the scalar triple product. Okay. So the first property is scalar triple product of A, B, C, if it is 0. If it is 0, then vector A, vector B, and vector C are coplanar. Okay. If scalar triple product of those three vectors if it is 0, then we can say that vector A, B, C are coplanar. Okay. Second case, vector A, B, C can also be written as B, C, A, can also be written as C, A, B. Okay, this is called as cyclic property. Means A, B, C, its next term you write. A next term is B, B next term is C, C next term is A. Again, B next term is C, C next term is A next term is B. Again, if you take the next term of this, again you get the first one. So they are in the cyclic. Okay. Third one, scalar triple product of AAB or ABB, which is equals to, it means what? In the scalar triple product, any vector is repeated, then always its value is 0. Always its value is 0. Okay. Next, fourth, scalar triple product of ABC is equals to, if in this scalar triple product ABC, among these three vectors, if you interchange any place of the vector, means what? For example, A, C, B. I have interchanged the place of B and C. So when you interchange the place of B and C, then that scalar triple product, you write it with the negative sign. Okay. This is one another property. Okay. So I think in the scalar triple product, you have to remember these properties to simplify the examples. Okay. So let us see the examples on the scalar triple product. Before going with the examples, we have to see the definition of scalar triple product. Means what? Suppose if the three vectors are given in the form, okay, I'll see the fifth one. Suppose vector A is equals to A1i, A2j plus A3k, and vector B is equals to B1i, B2j plus B3k, and vector C is equals to C1i plus C2j plus C3k. If the vectors are given in component form, then scalar triple product of A, B, C or A dot B cross C is given by the formula determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, means what? Those component form vector A components you write it in the first row, vector B components in the second row, vector C components it is in the third row. Okay, and that is what determinant. And after that, to find the value of this, as usual, our normal expansion by the first row. Okay. So these are the observations, or can also say properties of scalar triple product. Now let us see the examples, okay, based on this concept. So before going with the examples, we are going to solve some results which are very important for 3 marks. Okay, what is that? Prove that scalar triple product of A plus B, B plus C, C plus A is equals to 2 times ABC. 2 times ABC. Okay. So to prove this, we have to consider LHS. So LHS is A plus B, B plus C, C plus A. So here I have considered the LHS. Now as you know, so this scalar triple product of ABC, that is square bracket of ABC, can also written as what? A dot B cross C. A dot B cross C means this A, B, C can be written as A. I have to keep as it is dot the cross product of this. Okay, the same definition you have to apply here now. Okay, so which is equals to first term. See here, if it is a box product, okay, if it is in the square bracket A, B, C, then how it is written? A first term I have to keep as it is dot the next 2 terms cross product. Here also same. A plus B is the first term, so you have to keep as it is dot. Okay, what? Cross product of the next 2 means what? It is B plus C cross C plus A, or which is equals to A plus B as it is dot. Now take the cross product of this. How to take now? Take the first term from the first bracket, take the cross product with next 2 means what? B cross C plus B cross A plus next C cross C, next plus C cross A. Okay, now next A plus B as it is dot B cross C as it is plus B cross A also as it is plus now C cross C as per the property of cross product. If you are taking the cross product of same vector, its value is 0. So this is 0 here. Plus what is left? C cross A, or which is equals to, now from this A plus B, take the first vector, that is vector A, and take the dot product with all. Means what will get now? This is A dot first term B cross C plus next A dot B cross A plus A dot into 0 is 0. Next A dot C cross A dot C cross A. Okay, plus take B again multiply inside the bracket, that is B dot B cross C plus B dot B cross A plus B dot C cross A. Okay, now again you just observe here, if it is A dot B cross C, Then reverse, how we can write it? That is square bracket of these three vectors. Square bracket of these three vectors, that is A, B and C. So here also the same now. So which is equals to A dot B cross C means what? Square bracket of A, B, C plus A dot B cross A, it means what? Square bracket of A, B, A plus A dot C cross A can be done as again square bracket of ACA, okay, plus this is BBC, square bracket of BBC plus square bracket of BBA plus square bracket of BCA, okay, or which is equals to now, okay, or I will take it here, or which is equals to, now first term as it is square bracket of ABC as it is plus, now the by property of scalar triple product, if any vector is repeated its value is 0, so this is 0, this is 0, this is 0 and this is 0. So 0 plus 0 plus 0 plus 0 plus last term BCA as it is, or which is equals to ABC plus, so when I am explaining the properties or observations, in that one property I explained, that is cyclic property. So by that cyclic property BCA value becomes what? A, B and C. Okay, so ABC plus ABC, it is 2 times A, B, C. Okay, and that is your RHS. That is your RHS. Okay. Now let us take, I hope that you understood this. Let us take one more property of the same type. Okay, same type. That is scalar triple product of A, B, C plus D is equals to ABC plus ABD. This is also we simplify in the same manner. First we will take LHS, square bracket of A, B, C plus D, which is equals to, now as you have written here, the square bracket of A plus B, B plus C, C plus A, how we have written here? First term as it is dot the cross product of next two. Here also the same. First term as it is dot the cross product of next two. That is B cross C plus D. Okay, so which is equals to A dot. Take the cross product inside the brackets, B cross C plus B cross D plus what? B cross D. Now take the dot product inside the brackets, which is A dot B cross C, A dot B cross C plus next A dot B cross D, or which is equals to, now A dot B cross C is what again? Square bracket of A, B, C plus next A dot B cross D means what? Square bracket of A, B, B, and I think that is your RHS. That is your what? RHS is the proof part. Okay, so I hope that you understood with this properties or this result. Okay, in the next class we will solve some of the examples.